triangle.
What kind of triangle is that?
Well, it looks like I have two sides that are the same length, so I think it's an isosceles triangle.
Okay. What do you know about an isosceles triangle? That you said two side lengths are the same and one is different? Yeah.
Yeah.
Okay. All right. Good.
Because it looks like this length and this length are equal, and this one is shorter.
Okay. Okay. Can you make another kind of triangle?
I'm thinking if I made all three of them equal.
Oh, okay. Okay.
So I've got three equal lengths.
And what's that called?
That's called an equilateral triangle.
Okay. Okay.
And then if none of the sides were the same length, so if I could make a triangle like this, I would have a scalene triangle.
Oh, okay. So scalene is when they're all three lengths different, equilateral is all the same, and isosceles are is at least two the same.
Correct.
Okay. So what does that have to do with the interior angles?
I was going to say, I'm also thinking that when I made my equilateral triangle, I know all three lengths are the same, but it also looks like all three of my angles would be congruent as well.
Okay. Okay. So equal angular. Okay.
If on an equilateral triangle, if all three of my angles are the same size, in isosceles, I had two sides congruent.
Mm-hmm.
So I'm thinking that two of my angles might be congruent.
Might be. Are your interior angles obtuse, acute, right?
I have, in this triangle, I have three acute angles.
Could you make a right isosceles?
So two of my lengths would have to be this, or two of my sides would have to be the same length, but I would need a right angle.
Yeah.
So if I had a right angle here.
Yeah. 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 Okay. So you know that right angle is 90 degrees.
I know I have a 90-degree angle here.
Yeah.
These two sides appear to be the same length.
Okay. And then those two angles then are acute angles.
These two are acute because I know if this is 90 degrees, I know that these have to each be 30 degrees.
30 and 30 is 90? What do you
Or
think?
45 degrees, I'm sorry.
45. Well, what made you say 45? I'm just curious. What do you know? Do you know something about the interior angles of a triangle?
Well, I know this is 90 degrees, so I know together these have to be 90 degrees.
Why?
Because I know that I have to have a total of 180 degrees.
Oh, so an interior angle degrees on triangles are always 180 degrees? Mm-hmm. Go back to your isosceles and prove, equilateral and prove that.
Looks pretty equal.
Okay.
Does that look like an equilateral?
It's pretty close, yeah.
So I know if I have to have a total of 180 degrees, I know that if each one of them is 60, I have three groups of 60, so I have 180 degrees.
Okay. All right, what about a scalene? Go back to your scalene. You could actually have a right scalene, couldn't you? Because that appears to be right, but you also could have a...
So if this would be a right scaling because I have a right angle there, and none of my sides appear to be the same length.
And those may be the same or may be different. Could you do an interior angle that's an obtuse angle? Oh, so which one of those angles is obtuse, Jill?
This one right here?
Yeah, it's more than 90 degrees. But so you still have interior degrees, though, of 180?
Yes.
Okay.
So therefore, I know that since that one's more than 90 degrees, these angles are continuing to get smaller.
Yeah.
As that's getting larger.
Ooh, that's a good observation. That's a good observation. Well, let's do something. Let's look here at an equilateral triangle, and let's see if we can prove. Because Jill said that all interior angles on triangles have to total 180 degrees. So what I want to do is I want to prove this. So I'm going to take these interior angles, and I just want to concentrate on the angles, so I'm just going to rip them off. So if I put all three of these together, oh, that's pretty interesting. All three of those put together actually make a straight line. Let me see if I can draw the straight line and get me a point on the line. That may help us see it a little bit better. So this angle plus this angle plus the red angle, oh wow, it is. So we know that a straight line is 180 degrees. Actually, that's kind of like, I can't really write upside down because it would almost be like I need to move these up here. Let's do that where y'all can see that better. That makes more sense. So that straight line is 180 degrees because that's the degree of a straight line. So these three angles added together actually make up that straight line. So I think we just proved it off of the equilateral. Let's see if we can prove it off of a scalene. All right, so let's see if I colored that angle black and maybe one of them green and maybe one of them red. And again, I'm going to try to prove this. Now this, I think, that's almost like a 90 degree. So I know that's a right angle, an acute angle, and an acute angle. So let's see. I'm going to rip this one off, and I'm going to rip that one off, and I'm going to rip this 90 degree. So since that one's 90, I'm going to put it right here. And what I know about these two, they should add together to be 90 degrees if, indeed, all triangles are 180. So if I put the red one right here, then this little green one should, look at there. That's interesting. So there's a relationship here when you have one 90 degree. The other two angles on all triangles are going to total 90 degrees. Well, let's look at another kind. Now this was like an isosceles. And remember she said that that side and that side were congruent. And that side was the odd man out because it's actually longer. So let's see. We've got an angle here. And we've got an angle here. And what I know about these angles again, I can actually see this, is I can see that this black angle again is that 90 degree. Because that's kind of like my benchmark. If I know a 90, then acutes are smaller than 90 degrees and obtuses are larger. Okay, so let's see. I'm going to rip this one apart. So I'm taking all three. And remember the black one again was a 90, so I'm just going to put it here. So the green plus the red has to be another 90. Oh, there it is. So far we've taken three different triangles, and we've proved that the interior angles, which all triangles have three angles, and all three interior angles always add up to 180 degrees. So if I know one of them, or if I know two of them for sure, I can find the other one. If I know one of them's 90, I probably could figure these out if it was equilateral. But I think given any two dimensions, I will always be able to find the third dimension, and we'll work some in a minute. Let's look at one that maybe has an obtuse. Okay, so here was that example in C again. This is something that you can think about when you're taking your tax test. If you're trying to identify whether this angle right here is indeed obtuse, if I actually line this up, and let me turn it where you can actually see it, okay? So if you were looking at this line or this segment, and I come straight up, then actually I made a 90, and you can see that that angle goes behind it, so it's going to be greater than 90. So that's called an obtuse angle. So let's see what this one is then. So here's a green angle, which we knew was obtuse. That's a pretty big one. Then we know that this one's, boy, really, really small, and it's less than 90 degrees, so it's going to be acute. And then this one over here also is going to be acute. So let's rip these. So there's one angle, two angles, and three angles. Okay. So what I know is, wow, this one's definitely greater than 90. It comes way over here. It would have come straight up. Then I have to slide this little red one in. Then I have to slide this little black one in. And, yep, all three of those angles together still make a straight line. So I think we've just given enough proof to prove that the interior angles indeed all equal 180 degrees.